Lesson 2, matter constitution. What's mean by molecule? It's the smallest part of matter which can exist in a free state and keeps the properties of matter. Again, what's mean by molecule? It's the smallest part of matter which can exist in a free state and keeps the properties of matter. What are the properties of molecules? Number 1, they are always in continuous motion. Number 2, there are intermolecular spaces between them. Number 3, there are intermolecular forces of attraction between them. Okay, let's take everyone in details. Okay, let's make an activity to show that molecules are always in continuous motion. Step number 1, add some drops of potassium permanganate. Okay, it's a chemical substance. Okay, its color is violet. So to a glass containing water. Number 2, leave them for a while. What you can observe, the violet color of permanganate spreads through all the water. Okay, so what we conclude from this activity, that the molecules of matter, the matter is permanganate, okay, in this activity, are in a state of continuous motion in all direction. Okay, you can make this activity in your home by using ink. If you put a drops of ink in water, you make an activity like this, and you observe that the molecules of ink spread in the water. Okay, so molecules of matter are in a state of continuous motion in all directions. Molecules of solid move in oscillatory motion or limited motion. Okay, solid molecules move in limited motion. Okay, liquid more free motion, and molecules of gases are unlimited motion. Okay, unlimited motion. So we have molecules of solid, molecules of liquid, molecules of gas. Molecules of solid move in a oscillatory motion or limited motion. Molecules of solid, of liquid, more free motion. Molecules of gas, unlimited motion. Let's make another activity to prove that there are intermolecular spaces between molecules. The property number 2. Okay, intermolecular spaces. What mean by intermolecular spaces? Spaces between molecules called intermolecular spaces. Okay, step number 1. Put 300 cubic centimeter of water in a graduated cylinder. Then add 200 cubic centimeter of alcohol. Okay, observation. Okay, if you put 300 cubic centimeter of water to an 200 cubic centimeter of alcohol, the sum will be 500, but we observe that the sum of their volume will be less than 500. Our volume of mixture will be less than 500 cubic centimeter. So what we conclude, that there are intermolecular spaces between water molecules which are occupied by molecules of alcohol. Again, we conclude from this activity that there are intermolecular spaces. It means spaces between molecules, okay? Between water molecules which are occupied by molecules of alcohol. Okay, let's make an activity to show that there are intermolecular forces between molecules. This is the property number 3. Okay? Step number 1. Try to break an iron piece into small parts and try to separate an amount of water into portions. What we observe, you can't break an iron piece without using special tools. You can easily separate the amount of water into portions. Okay, so what we conclude from this activity, Intermolecular forces of iron are strong. Okay, intermolecular forces of iron are strong. Intermolecular forces of water are medium. So we conclude from this activity the intermolecular forces among solids and liquids. Okay, among solid, they are strong intermolecular forces. So we can't break an iron piece. But among or through water, the intermolecular forces are medium. So we can separate the amount of water into. Give reason. Number 1, a drop of ink spread through water. Drop of ink, you remember, like potassium permanganate, okay? So what is the answer? Because molecules of ink are in a state of continuous motion in all directions. Again, a drop of ink spread through water because molecules of ink are in a state of continuous motion in all directions. Number 2, smell of perfume spread all over the room when the bottle is opened because the molecules of perfume spread in the air carrying the properties of matter because the molecules keep the properties of matter. Okay? Number 3, volume of mixture of water and alcohol is less than the sum of their volumes before mixing because molecules of alcohol spread in the intermolecular space. Okay, let's make a comparison between solid, liquid, and gas. Okay, intermolecular spaces, okay, and intermolecular forces, shape, volume, and motion of molecules. Solid molecules, the intermolecular spaces are very narrow. Intermolecular forces are very strong. Shape is definite. Volume is definite volume. The motion is oscillatory motion or limited motion. Okay, liquid intermolecular spaces are medium, forces are weak, shape indefinite shape, volume definite, and the motion of molecules are more free. Gas, large intermolecular spaces, very weak intermolecular forces, indefinite shape, indefinite volume, and the motion is unlimited or completely free. So this is a summary. This is a summary for the properties of molecules through solid, liquid, and gases. Okay, middle one. Okay, gave reason. Gases have definite shape and volume because gases have very weak intermolecular force and large intermolecular spaces. Solid have definite shape and volume because solid have very strong intermolecular force and very narrow intermolecular. The change of matter, okay? Change of matter from solid state to liquid state, okay? Like ice changes to water by heating. Why? Because heat energy decrease the intermolecular force, increase the intermolecular space. So increase the velocity of molecule. So solid changes to liquid again because by heat energy, the intermolecular space increase, intermolecular force decrease. So the velocity of molecule or the speed of molecule increase. So solid changes to liquid. So what's mean by melting? It's a change of matter from solid to liquid state by heating. Okay, as you see in this picture, ice changes to water by heat. Okay, the change of matter from liquid to gas. As you see in this picture, liquid changes into water vapor or water changes into water vapor by heating. Water or liquid changes to water vapor by heating, okay, because heat energy, again the same as we said from solid to liquid. Decrease intermolecular force, increase intermolecular spaces, increase the velocity of molecules. So liquid changes to gas or vapor, okay. So what's mean by vaporization? It's a change of matter from liquid state to matter and molecules. Matter consists of molecules. Molecules of the same matter are similar. Matter consists of molecules. Molecules of the same matter are similar. Molecules of different matter are different. So molecules consist of tiny units called atoms. Again, matter consists of molecule. Molecules of same matter are similar. Molecules of different matter are different. Okay, and molecules consists of a tiny units called. Okay, what are the types of molecule? We have two types, element and compound. Element is the simplest form of matter which consists of similar atoms. Okay, compound, it's a substance which contain different atoms with different or with constant ratio. Again, compound, it's a substance that consists of different atoms with constant ratio. Element is the simplest form of matter which consists of elements divide into monoatomic element and diatomic element. Monoatomic, it means that the molecule consists only of one atom. Diatomic means that the molecule consists of two similar atoms. Monoatomic, like inert gases, okay, or inactive gases. Only one liquid is monoatomic, which is mercury. All solids are monoatomic, like iron, copper, sulfur, and carbon. Molecule that consists of two similar atoms, diatomic molecule, like only one liquid is diatomic, like bromine. All gases, all active gases are diatomic except the inert gases. Okay, يبقى oxygen, hydrogen, nitrogen. So inert gases are monoatomic. Active gases are diatomic. Mercury is monoatomic. Bromine is the only liquid diatomic. All solids are mono. Okay, water molecule, the number of atoms, 3 atoms. Number of elements, 2. Okay, let's count how many atoms in this molecule H2O. We have 2 hydrogen and 1 oxygen. So the total number of atoms is 3. Number of elements, we have hydrogen and oxygen, so we have 2 elements. Okay, 2 hydrogen atom and 1 oxygen atom. Okay, sodium chloride, number of atoms 2 and number of elements also 2. We have sodium and chlorine, so we have 2 elements. We have 1 sodium and 1 chlorine, so we have the number of atoms are 2. Ammonia molecule, number of atoms 4, number of elements equal 2. Okay, we have 1 nitrogen and 3 hydrogen, so the total is 4 atoms, and we have 2 elements. We have nitrogen and hydrogen, so we have 2. Okay, let's make a comparison between element and compound. Okay, what's mean by element? Element is a substance whose molecule consists of similar atoms. Okay, atoms are similar. Elements like hydrogen, oxygen, aluminum, and sulfur. Compound, a substance whose molecule consists of 2 or more different atoms of different elements. Okay, atoms are different. Water, carbon dioxide, sodium chloride, and calcium carbonate. These are examples of compound. Okay. Give reason. Different molecules have different properties because they have different structure. But right or wrong, molecules of the compound may be monoatomic, diatomic, or triatomic molecule only. The answer is wrong. Element is not compound. Okay, molecules of elements, okay, may be mono or di or triatomic. Okay, molecules of some element consist of more than 3 atoms. No, the answer is wrong because a molecules of compound consist of more than 3